Okay, next we're going to look at the sensations of taste and smell. So this block will be on taste. So taste is a sensation that relies on taste buds in the tongue and also in areas of the pharynx. So taste sensation requires taste buds. These are your taste buds that sit in the tongue, and each taste bud has a taste pore that these creates access to taste cells. These are taste cells in your taste bud. And each taste cell is linked to a sensory neuron that would carry the message up to the brain. All right, so these are taste cells. This is a taste pore. And the chemicals enter the taste pore to activate your taste cells, which then generate an action potential in your taste nerve. So there are 5 different taste sensations. You have your sweet taste due to sugary chemicals in your meal. You have your sour taste caused by the presence of H pluses, protons, in your meal, like lemon juice, for example, tomato juice is that such a thing. And then you have sweet, sour, you have bitter. Bitter is due to nitrogen containing compounds, caffeine, for example, to create bitter sensation, bitter taste. Then we have your, what's next here? Salty taste. That comes from the presence of sodium and potassium ions in your meal. And then we have umami. Your umami taste is more of that meaty taste, that sweet, savory taste to your meal, usually caused by amino acids, especially glutamate. Can trigger that umami sensation, umami taste. So we're going to look at these 5 different taste modalities and discuss some of the cellular mechanisms that create the taste for you. So let's begin with the taste of salty. So salty and sour are what we call direct sensations. These chemicals can directly enter your taste cells to trigger local potentials and action potentials to create the sensation. So let's begin with salty. For this one, if this is your taste cell, a taste cell in, say, a taste bud, and this taste cell will have gates on it, okay? And these gates will let in sodium or potassium. So that's step 1, entry of ions into the taste cell. And these ions so they come in, they create depolarization. And that depolarization will next open voltage-gated calcium gates on the same cells that will let calcium into the cell. So that's step 2. Step 1 is entry of the ions to depolarize the cell, which then opens up voltage-gated CA channels to let calcium into the cell. And then calcium will trigger the cell to release NTs. Okay, that's step 3. NTs are released, and then those NTs will activate the neurons to create action potentials. And so you can sense salty that way. So again, step 1 is sodium, potassium, enter. That will depolarize the cell to open up voltage-gated CA channels. Then CA enters, and CA enters will trigger your vesicles to release NTs, which will then activate the taste neuron. Okay, that's salty. Similarly, sour has a very similar mechanism of action. So again, here will be your sour cell. And it also has gates on it. And the gates on this sour cell will let in H pluses, protons, into the cell. They enter, and again, that will depolarize the cell, and that will open up voltage-gated CA channels, which lets calcium into the cell. Then that calcium then will trigger the release of NTs to activate your sour neurons. So that's salty and sour, where these things act directly on the cell. They can enter the cell directly to trigger the effects. The next three taste sensations do not act directly. They act indirectly using what's called second messenger systems. So we'll look at that one next. So we begin. This is sweet and umami, similar mechanisms. So sweet and umami, those use similar pathways to do together. So here again, this is your taste cell. This time, the receptors on the taste cell that respond to your sugary things or your amino acid things, they will bind to the receptor, but they will not enter the cell. And that will trigger a peripheral protein called a G protein. And that G protein can act as an enzyme or an initiator to eventually make something called a second messenger. And that second messenger in this case will close potassium gates. So if you close the gates, that means potassium can't leave, and that will cause a depolarization in the cell. And then that depolarization will trigger again the release of NTs to activate the neuron to generate an action potential. So just to review it again, the chemicals bind to receptors on the cell directly, on the cell, then that receptor will in turn activate a protein called a G protein. Then that G protein will trigger a second chemical in the cell called a second messenger. And that messenger, which we're not telling what it is, will block your potassium gates. And usually, if the gates are open, your Ks can leave. So by blocking the gates, the Ks can't leave, and they will instead accumulate in the cell to depolarize the cell. And that depolarization in turn will cause you to release NTs, which will then trigger an action potential in the taste nerve. So that is your sweet and umami. Okay? Next one, we'll do bitter, which is very similar. Again, acting indirectly. Here's the cell. So again, receptor here. So your bitter chemicals, like caffeine, for example, will bind to the receptor there. And again, you create a G protein will get activated. And that in turn will generate a second messenger. And that second messenger in turn will cause the ER, your endoplasmic reticulum, to release calcium. And then that calcium in turn will trigger the release of NTs to again generate an action potential in the taste nerve. So there we have it, your 5 taste modalities and how they work. Thank you.